Often in physics, if not all the time, the question is asked, how do you solve a problem? You see, by definition, a problem is tough because it's a problem. And here I'm just trying to show you a 6-step method that you have to absolutely use in order to do a problem. You cannot jump into a problem. You cannot go by, just what comes into your mind without reading the problem. So there are 6 steps that you need to do. So this video is called How to Solve Problems. The number one step and the most important step is to read the problem carefully. That means you read it until you get a good idea of what the problem states. As an example, here is a problem that talks about a toy rocket moving vertically upward, passes by a 2-meter window whose sill is 8 meters above the ground. Now, could you visualize that? And the rocket takes 0.15 seconds to travel the 2-meter height of the window. What was the launch speed of the rocket and how high will it go? Assume that the propellant is burned very quickly at blast off. Now, if you look at the important points in this question, you would find that it's moving vertically up. That's very important. The height of the window is 2 meters, but the bottom of the window is 8 meters above the ground. Rocket takes 0.15 seconds just to travel the 2-meter part of the window, and you have to find the launch speed, how high it will go. So those are the 2 questions that you have to find. With what speed it blasted off and how high it will go. Obviously it's going to go much higher than the top of the window. And then there is an assumption that the propellant just burned off quickly, in a millisecond or in a tiny bit. So now that you've read the problem, the second step is to draw a diagram. For almost all physics problems, you do have to have a visual representation of what you got from the question after reading it. In this case, that's the ground. This is 8 meters above. That's the bottom of the window. And the height of the window is 2 meters. So now that shows the rocket being propelled up. And the question says it takes 0.15 seconds just to move across the window. Now, see, that gives you a visual representation of the problem, which is very important. And then the next step is to write down the given terms. Because, in formulas, there will be so many terms, and you got to know what each term stands for. In this case, we know that since the object is moving up, it's slowing down, so its acceleration is negative 9.8 meters per second squared. And let's say that the velocity at this point is v naught and the launch velocity is vl. Okay, and therefore if you look at just the first part here, you have to find v naught here. You don't know that. The delta y is 2 meters and the time for that part is 0.15 seconds. Now, after you write down all the given terms, the next step is to pick the equation that has all the terms in it. Now, that's an important thing. You got to look at the terms carefully. It's got acceleration, it's got v naught, the initial velocity, it's got delta y, and it has the time. Now, which is the equation that has all these terms in it? And the obvious answer is, when you look at the formula chart or formula sheet, you're going to find this equation has all these terms, including the unknown, remember. Because you got delta y there, you have V naught, T, and A, and again T. Once you have the equation, you have the plan now that in this equation you know all the terms except V naught. So you're going to get V naught. Let me draw that again. That is the window part. And because you got the equation, the next step is to substitute the terms carefully into the equation. So substitute all the terms and then calculate. It'll be a good idea to write the units along with, but most of the time I don't, just to save some time. And then you have to calculate, and you have to be careful when you calculate. You have to realize there are two terms here, that this is the second term, and you just got to write that second term down. It comes out to be 0.11, and that's the first term. And then you got to switch the sides, and there's already a 2 on the other side, so 2 plus 0.11 is 2.11, and you get V naught is 2.11 divided by 0.15, which is 14.07 meter per second. Now, since you got that, now we can use this equation. V naught squared is equal to V launch squared plus 2 A y or A delta y, and make the velocity of launch the subject, and you're going to get this equation, into which you carefully plug the numbers. That's what you got just now. And you get 18.8 meter per second. Now that we have the launch velocity, we can go back and find. Now remember, that was one of the questions that was asked, and that's answered. Now we got to find out how much higher it'll go. Okay, we got the launch velocity, so we can one more time use the same equation. And we do know that at the highest point, its velocity is 0, right? So in this equation, when you rearrange, make delta y the subject, you notice that the final velocity is 0, because that's the velocity at the highest point. And I've included a correct number here, which is 18.84, which is what I got. So that's why you see that there. And once you get those answers, you evaluate the answer. You look at it and say, is this logical? Is it okay? Could it be these? Could these numbers be correct? So many times you can actually find out if you've made a silly calculation mistake. If you just think about the answer. In this case, the answers look good because, the launch velocity is 18.8. Velocity when it reached the bottom of the window was 14.07. Of course, it should be smaller. It goes up to like 18.1 meter. Now, so these are the 6 steps of doing a problem. Let's go back over it again fast. Number 1, read the problem carefully. Number 2, draw a diagram. 3, write down the given terms. 4, pick the equation. 5, substitute and calculate. And then 6, evaluate the answer. And I hope this has helped you. Look at this video many times until you practice these steps. Thank you.